Hi everyone, welcome to the course of low level design, LLD. This is also called LLD. Now in this course curriculum, first of all we are going to see the solid principles. What are solid principles? So solid principles are nothing but a set of design principles in object oriented programming that help in creating software that is easy to understand, maintain and extend. Okay. uh, so what are the solid principles? So solid principles, they are basically five principles. Solid stands for, S stands for single responsibility principle. O stands for open close principle. L stands for Liskov substitution principle. I stands for interface segregation principle. And D stands for dependency inversion principle. So these principles are basically important for the developers, so that the developers can create code that is more or less modular, flexible and maintainable. So uh, what it does, it just promotes separation of concerns. So basically separation of your functions, your classes, and your responsibilities, I would say. It reduces coupling. We'll see what are concerns, what are coupling. So coupling is more or less a dependency of classes or the attributes, or the entities, like the objects of a class, like they are like tightly dependent or loosely dependent on each other. So if they are tightly dependent, then they are highly coupling. So we have to reduce the coupling. We will see what coupling means. So it like solid principles helps to reduce coupling, which is a great thing. It improves code reusability and facilitates the design of robust and scalable software systems. So these are some of the things that are provided when we are following set of these principles. So the solid principles, these are given by Uncle Bob, and so these are given by Uncle Bob. You can search about him on the internet, and these are basically the principles. Okay, now in this video we are going to talk about the single responsibility principle, and always remember that these principles are basically for object oriented programming. So we are going to use Java to understand the coding part. Why not C? Because C does not support object oriented programming. We can use C++ and or Python as well, but I am using Java because we have to understand uh, with the help of interfaces also. So interfaces are there in case of Java, so we are going to use Java. And also Java is purely an object oriented programming language, so we are going to stick to this language only during the whole course of low level design. Okay, so low level design basically deals with object oriented programming. Okay, so before starting the solid principles, I would like to go through the LLD course curriculum. So basically, first of all, what we are going to do, we are going to learn the solid principles. Then again we are going to see 12 design patterns, like factory patterns, uh, abstract factory patterns, uh, and there are various other patterns, like total 12 patterns are there. So these are basically the um, patterns that are useful in object oriented paradigm. So we will see 12 design patterns after studying the solid principles, and these patterns will obey the solid principles, this set of rules. Again, what we are going to do, we are going to do some case studies. Case studies means that we are going to deal with various case studies. We are going to um, code uh, some uh, real time interfaces, like we are going to see how we are going to design a ticket system using object oriented programming, and we will be obeying these set of rules, these set of design patterns. And before beginning, I would like to tell you to have some basic idea of UML, that is unified modeling language. You can learn it. I will be uploading a playlist on UML as well. So after learning unified modeling language, it's not very much a hard thing. You must at least have some idea of class diagrams, I would say. Class diagrams. So basically class diagrams I will be explaining it. The class diagrams I will be explaining it. So you must have some idea of the UML, that is unified modeling language, before getting into the solid principles and all those things. But even if you don't have the idea of UML and class diagrams, I would be explaining some of the concepts in this video, then I will be moving forward. Okay, so let's jump towards the single responsibility principle. So this is also called SRP, single responsibility principle, SRP principle. Now, what does it say? What does SRP principle say? So as the name suggests, the single responsibility principle, it states two key principles: that your class or method should have only one reason to change, and your class or method should only have one responsibility to take care of. Okay, so what does that mean? So when you design your logic in either class or method, you should not be writing all kinds of responsibilities in one place. If you are writing all kinds of responsibilities in one place, it will make your code complex and it will be quite unmanageable. So it will be very much difficult for you, for the developers, to um, adjust new changes later, as there are high chances that it will also affect other functionality, and you will end up testing and debugging all the functionalities even though it is a smaller change. So let's take an example. Suppose SRP says that it is single responsibility principle. So it means, suppose you have a class, suppose, and this class is having some functions. Suppose this is function 1, this is function 2, this is function 3, this is function 4. So suppose this function performs one uh, one operation. Suppose this performs addition, this performs subtraction, this performs printing operation, this performs this performs, suppose, multiplication. Okay, so you can clearly see that this is only a single set of operation, this is also single set. So these functions are operating some single set of operations, so they are having only one responsibility, so they are obeying the single responsibility principle. So these functions are obeying the single responsibilities principle. But if you will see the class, this is not obeying the single responsibility principle. It is, what it is doing, it is doing some arithmetic operations and also one printing operation. So this is not a single responsibility that this class is doing, so it will create certain difficulties as as if we want to make some changes in the class, so we would have to look for each and every functionalities. So one better idea is to club the same set of responsibilities together, and so that we can take care of SRP principle. So we can club these things together, these arithmetic operations together, and we can separate this print operation, and we can create another class for printing. So I am creating another class for printing. Okay, so this is what SRP states. Now let's take another example. So suppose you have a class invoice. Class invoice, and it has a method add invoice, delete invoice, generate report, and email report. So add invoice, if you will see, add invoice, delete invoice, they both are same set of operations, and generate report, email report, they are another set of operations. So but if you will see that these all methods are obeying the SRP principle. So add invoice is obeying the SRP principle, delete invoice is obeying the SRP principle, generate report is obeying the SRP principle, and email report is also obeying the SRP principle, because they all are doing only one task, that is, it is adding invoices, it is deleting invoices, only one task is done, generating report is another task. So these four methods are obeying the SRP principle, but this class invoice is not obeying it, because this class invoice is not performing same set of responsibilities. It is having different methods which are doing different set of operations. So what we can do, we can club the same set of operations like add or delete invoice. So this can be clubbed together, and generate report and email report can be sent to another class. So it can be have, we can have another class for this, okay, we can have another, okay. So as the name indicates, SRP principle, as the name indicates, it states that all classes and modules should have only one well defined responsibilities as per Robert C. Martin. So Robert C. Martin, he is the one who is called Uncle Bob, as I mentioned in the video, in the beginning of the video. So this is the thing. So single responsibility is like, I suppose that single responsibility principle is clear. So a class should have one and only one reason to change, and a class should have only single responsibility, okay. So generally in long running softwares or applications, as and when new requirements come up, developers are tempted to add new methods and functionality to existing code, which makes the classes hard to test and understand. It is always a good practice to look into the existing classes and see if the new requirement fit in the existing class, or should there be a new class designed for the same. So what are the benefits of SRP principle? So talking about the benefits of SRP principle, if you talk about the benefits of SRP principle, so for testing and writing test cases is much simpler. So testing becomes simpler, code quality increases, so the code quality increases, and as we have made modules, that are performing same set of responsibilities, so we can hire new members and they can contribute much faster. So hiring process is also increased, and an application with multiple classes if they are performing this principle, so we can maintain the application easily because they are divided into modules and it becomes easier to understand. So the complexity of the code decreases, and testing becomes simpler. So these are some of the benefits of the SRP principle. uh, Now there are various practical life applications, real life applications of SRP. So it is used it is used in Spring Data JPA, which takes care of all the CRUD operations. It is used as writing boilerplate for JDBC code to store entries in databases. It is used in Spring framework as well, and there are various practical real-time uh, uses of this SRP principle. Okay, so single responsibility principle, like let me just recap you what SRP principle is. SRP principle is nothing but it only states that the classes or the modules or the functions must have only one reason to change, and the classes or the functions must have only single responsibility, so as to maintain the code flexibility, so that the user so that the developer who is like willing to update or make new functionalities does not have to uh, go through the testing and debugging phase again and again, and it takes very less time to design the test cases uh, for that particular program that the developer is working on, as the program is divided into modules due to this SRP principle. So this leads to various benefits, like the testing or debugging becomes simpler, code quality increases, so we can and the program is divided into modules so that we can the new members that we hire can work on the modules, and the complexity of the code also decreases. So these are some of the benefits that SRP principle provides, and this was the idea of the SRP principle. Now let's see with an example. Let's see with an example of SRP principle. So I'm going to take one UML diagram, and then we are going to uh, code 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 the UML diagram. Yeah, it's like I'm going to take the class diagram, UML class diagram. I'm going to take UML class diagram so as to make you understand what SRP principle is trying to say and how SRP principle works in low level design. So let me take the example. Okay, so this is the given UML class diagram, and we can clearly see that we have four classes. The first class is customer, second class is order, third class is bill calculation, and fourth class is delivery app. Now you might be wondering that what is this, like it's very big, and like you don't need to fear seeing this. It's just when we will implement it, you will see that it's not much of a deal. You can actually create this class efficiently if you have some idea of the core concepts of object oriented programming. Now let me just explain you what this representation is. So this is the basic class diagram of under the UML language. So you can clearly see this is a customer class. It's a customer class, and these are the data members. These are the data members. and these are the member functions. These are the data members, and these are the member functions or constructors. So we can clearly see for the data members we are having let me write over here. So plus, minus, and this hash. So plus represents it is public, minus it is private, and this hash represents it is protected. Okay, so we can clearly see name is a variable whose data type is string, and which is private. So it just represents private name, private string name. So this is private string name. So this customer class has a data member name which is of data type string, which has a data type string and is private, which means only this class can access its the name variable. Okay, so in the same manner this address, and again if you will see get name, so this string is not this data type, it's a return type. So get name is a member function of this class customer which is public, and its data type is a string, return type is a string. Set name is a member function which is public in customer class whose return type is void. So this is what it is, and you can clearly see here it is get customer is a date. What is this get customer? Get customer is a member function whose return type is customer, which is a class, and it's a public. Okay, now one more thing, like if you will see these two classes, so here I have written no return type, it is blank over here, and the name is same, bill calculation, for delivery app also, delivery app and delivery app. So and it does not have any return type, so it's a constructor, public constructor name, and this is a constructor what I have written over here now. So this is a constructor now. So this is basically what class diagrams looks like. It is the static view of you can say it is the static view of your uh, classes. Now we are going to implement this this UML diagram using Java. Okay, and we will see how this is following the SRP principle. So you can clearly see it is following the single responsibility principle. What customer class is doing? Customer class is doing taking customer's name and getting customer addresses and setting customer address. So it has getters and setters for customer only. So it is following the SRP rule. For the order as well, it has methods such as customer order, set customer, or getting order ID, setting order ID, and getting quantities, setting quantities, getting bills, preparing order. So this is following single SRP principle. When does SRP gets violated? When if we had these methods in this class or these methods in this class, so SRP would have been violated, but it's not the case. If we see the bill calculation also, it's following SRP principle, it's calculating bill, and the delivery app is also having functions related to delivery. So all of the classes are following SRP principle. Now we are going to code it out. So hi guys, welcome back. Now we are going to see the code for the same. So we have created one customer delivery .java file, and in the right side I am having that snap of the 4 different classes that are following the SRP principle. Now let's just try to write down the code for the same. So we have one class customer, so let's start. So customer class, what is the role of customer class? So where did it went? Okay, what is the role of the customer class? Basically the role of the customer class is to get and set the name. So it has only getters and setters. So let's try to write out. Now you can clearly see with the help of UML diagrams how the code becomes very much easy. Like we can code it very much efficiently without producing much error. So let's try to write it. Class customer. Now class name, always start with capital letters. So we have a class customer and it has private string name, it has private string address, it has private string address. Now it has a public get name, public return type is string, and it is get name method, and it is going to take it is going to return the name. Okay, get name is going to return the name. Okay, we have a public void set name, and it is going to take string name, and this is going to set this dot name equal to name. Remember, this is a keyword, a special keyword used to access the private members of the same class. Public, so get name and set name done. Now I have to do get address. So it is public get address. So get address return type is string, get address, get address, get address, and its return type is string, and it is going to return the this dot address, or simply address. Okay, simply address. And we have public void set address, and it is what it is going to do, it is going to take one address parameter, and this is going to set this dot address equal to address. Okay, this is done. So this is the class. So this class is following the SRV principle. As I said, it is only getting and setting name and getting and setting address. So getters and setters for name and address for class customer is done. Now again we are going to make this class, this particular class. So this is the order class. Okay, this is the order class. Class order, and I'm going to create a private customer private order ID, and its data type is string. So with the help of UML diagrams you can clearly see how efficiently we can code private item name, it's string, actually string item name, private int quantity, private its bill amount, private int total bill amount, its private total bill amount, private total bill amount. Can so write it as AMT private bill amount, total bill amount. Okay, now again in this the member functions or the constructors that we have, no constructors, we have one get customer. Okay, its return type is customer, so public get customer, and its return type is customer, and it will return customer. Okay. We have set customer, so we have public void set customer, and it is going to take uh, customer as a parameter, and this will just set this dot customer equal to customer. And we have one more method, get order id, public get order id, so it is string get order id, and it is going to return the order id. Again we have public void set order id, this will take string order id, and this will just do this dot order id is equal to order id. And again we have get item name and set item name, public string get item name, return item name, public void set item name to be set item name, so it's going to take string item name. Okay, set item name, it's going to take item name, string item name, and this is going to set this dot item name to be item name. Okay, this much is done. Get item name and set item name. Now get quantity and set quantity, public int get quantity. See, I am following the camel casing, and it's the best method you can implement. Public int get quantity, and it should return the quantity, and public void set quantity, so this is going to set the quantity, so it is going to take int quantity, and this dot quantity equal to quantity. Again get total bill and set total bill, so public void get total bill. Okay, it's get total bill, so it's of type int, and we have to just turn total bill amount, and public int set with public void set total bill to be this dot total bill amount is equal to print total bill amount, okay. And again we have one prepare order, so public void prepare order, this return type is void. Now here, so we have created this very much big class which is like implementing which is having various member functions. This class is having various member functions, as you can see. Now what we have to do, we have to basically create one prepare order. So what I will do, just I am just going to print something here. So what I am going to print, I am going to print the customer name and also item name, okay. So for prepare order I am just going to print the customer name and item name, okay. So let me just write it out. System.out.println preparing order for customer, and I am going to print this dot get customer dot get name, okay. So what this will do, eventually it will call for your get customer method which is present in this class only, okay. You can clearly see get customer is present in this class only, and it will again call for get name method which is there in get customer. So this dot get customer will return your customer object, and you are calling get name from this customer object. So customer class is having customer object and customer object. So in customer class you can see here we have one get name. So in this way it is working. Now what I am going to do over here, I am also going to so this is the name of the customer, and I am going to get the item name as well. So I will just try it over here. Who has ordered, like this person who has ordered some what is the name of the item. So this dot item name, this dot item get item name, okay. Get this dot get item name. So this dot get item name will give me what, it will going to return me a string which is the item name, and get item name is already there in this you can clearly see get item name is already there. So with the help of getters and setters this method is working. No like it's not very much complex, it's just a easy piece of code. Now let's try to write down the bill calculation class. So we have a bill calculation class bill calculation, okay. This is the bill calculation class. So always start class capital letters, bill calculation class. And in this I am having a private data member, private order. Now order is a class and order is an object. I have one bill calculation constructor. So let me write over here bill calculation. So bill calculation, it's a constructor. It does not have any remember constructors do not have any return type. So it's just a constructor bill calculation, and in this bill calculation, what I'm going to do, I'm just going to take the order first. So what the order we have, and I'm just gonna write this dot order equal to order. So we are taking the order for bill calculation. Now what I'm going to do, uh, I'm going to write a calculate bill method. You can clearly see here we have a calculate bill method. So public void calculate bill, public void calculate bill. And in this calculate bill, what I'm going to I am going to calculate the bill. So let's say, how can we calculate a bill, in real world, we want a kind of lookup uh, that implements the price of each item included in the order. Okay, so yeah, what I was saying that I have to calculate the bill. So what I will do basically, I am just going to simulate the real world scenario. So I am going to create a rand. I am going to get a random integer, random rand equal to new random, and I am taking one int, total amount, which is rand dot next int, let's take 200 times this dot order dot get quantity. So get quantity will give me the quantity of the things that I have ordered. And now I'm going to do this dot order dot set total bill, and I'm going to add total amount into it. And again I can print out system dot out dot println. I can print out order with order ID, order with order ID. So you can clearly see the order ID is over here, get order ID. So this dot order dot get order ID, so it will return with order ID. Order with order ID is having total bill of, plus is having total bill of this dot order dot get total bill. It will give me the total bill. Okay, this much is done. So we have calculated the bill calculation. So I have done I have taken any random number and multiplied it with the total quantity. So like this I did it over here, so just to simulate the behavior of practical scenario. And now bill calculation method class is created. Now I have to create a delivery app class. So let's create a delivery app class. So class delivery app, it's having one private order, and it's having one constructor public delivery app. Okay, it's having a constructor delivery app. And what I am going to pass over here, I am going to pass over order and this dot order equal to order. Okay, so with the help of a constructor I have passed the object of order. And now what I am going to do, I am going to just write one delivery method. So here we can clearly see we have a delivery method. So public delivery, its return type is void. So this method, what this method will help, so it will I want to get the order ID, customer name, and where this order is being delivered to. So I will just system.out.println, it is going to print the order ID which is to be order dot get order ID plus what is the customer name. Okay, is being delivered to customer name. So this is this dot get this dot order dot get customer and in this customer we have get name method. Okay, get name, and again what I am going to do, I am going to system.out.println, I'm going to see the see where the address of the customer is. So order is being delivered to plus I am going to take this dot order dot get customer dot get address. So in this way I am printing all the necessary details. So here I in this class what I am doing is basically how the system assigns the tasks of delivery to different persons based on location. I am trying to print that out with the order ID and its location. So this is the whole function that we have created, and I have imported a till.random import java.io.all and a customer class, order class, bill calculation, and delivery app class is done. Now let's create the main method. So class customer delivery, the file name, and public static void main string args. Okay, and now we are going to create the main function so that we can implement all the functions that we have written till now. So let's create one customer one. So we have a customer one, new customer. Okay, one customer created. Let's see customer one dot set name. Let's set it as John. Customer one dot set address, let's set it as you can set it as suppose Delhi. It's not a full address, but although okay, now what I'm going to do, I'm going to create object of class order one. So I have to make one order for him, is equal to new order, and what I'm going to order one dot set item name. So let's suppose I am wanting to order pizza. Now order one dot set quantity, how many quantities that we want, suppose 2 quantities, and order one dot set customer. So for which customer I am ordering? For customer 1 I am ordering. Now I will just do order 1 dot prepare order. So it will prepare the order, and let's create bill calculation. Bill calculation is equal to new bill calculation for order 1. So I have to calculate the bill for order 1. Now I will just call bill calculation dot calculate bill. So I will calculate the bill, and again I will create one delivery app. Delivery app is equal to new delivery app, and I will pass here order 1, and I just want to see delivery app dot delivery, where it is being delivered to. Okay, so this is the main method that I have written. Okay, let's try to run it. Okay, now preparing order for customer John, who has ordered pizza. Order with order ID. I haven't set the order ID. Having total bill of this is a random number, and order ID is not known, and customer name is John, and order is being delivered to Delhi. Okay, so we could also set the order ID as well. It's not any problem, or you can actually set order ID to be any random number as well. That doesn't matter. Now let's see what we did actually, the overall thing that we did. So first of all we created this customer class, and set all the names, addresses of the customers. Now we created a order class to create one order, like how many, what things the customer requires, what is the order, that order ID, what is the customer, for which customer we are ordering, and how many quantities, and we are also have declared get total bill and set total bill, and prepare the bill. And for bill calculation we took the order, and we calculated the bill using some random numbers to simulate the real life scenario. And again what we did, we created one delivery apps to show whether to which customer we are delivering the product, and the quantity and all those information, and the location is shown through this delivery method. And how these classes are communicating with each other. So every classes are accessing its public methods via the through its objects of that class, which are being passed as the parameters in constructors call, or actually declared as private functions. So in this way they are communicating. And also you can see that each class is following the SRP, that is single responsibility principle. So in this way we have seen the working of SRP principle, how these classes are not violating the SRP principle. And what is the advantage of this thing is, the advantage is basically like if we want to implement, like suppose if we want to change some behavior, so we can create one new class, if we make some changes in this order class, because of its modularity it will not affect the customer class, so there will be no dependence, and there will be less number of errors, and testing and debugging would be much easier. So that would be very much helpful for any software implementing this kind of approach. So this was all about SRP principle, and in the next video we are going to see the open close principle.